Alright, in this video we will learn how to graph radical functions such as these, and we're going to graph them in terms of transformations by comparing them to the parent function. Alright, so here's the parent function. So understand that if we're doing the square root and we're going to make a table of values, you can't take the square root of a negative number, at least not without introducing imaginary numbers, which we're not prepared to graph right now. So we're going to start the table at 0. So I'm definitely going to go with 0. Now, considering that it's the square root, if we want to have nice whole numbers to work with or something like that, it would be advantageous to use perfect squares. So 0 works because I can take the square root of 0. 1 is a perfect square. And then after that, let's do 4. And after that, let's do 9. So I'm really going to stick to these 4 values to anchor me and guide me. Because if I substitute these into the function 1 by 1, I have the square root of 0, of course, is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So these 4 points will give me a pretty good idea of what the function looks like. So I'm starting here at 0, 0, and then I've got 1, 1, and then it's 4, 2, and then it's 9, 3. So this gives us a pretty good idea of what the function, the square root of x, looks like. Okay, and what it is if you picture a parabola, a sideways parabola, this is half of a sideways parabola. Okay, so that's what the parent function looks like. Now we're going to do transformations to this. We're going to move it up, down, left, right. We're going to do vertical stretches. We're going to reflect it, but it will be helpful if we sort of keep in mind a pattern that we see here. As we go from the first point to the second point, notice that these are 1 apart horizontally. From the second point to the third point, it's 3 apart. And then from the third point to the fourth point, they are 5 apart. So it's like 1, 3, 5. If we sort of memorize it, things will go much more quickly. Alright, looking at problem number 1, you can see that compared with the parent function, we have some modifications going on here. When you're adding and subtracting on the end of a function like this, that's going to be a shift up or down. And positive would be up, negative would be down. So this is a translation that is up 3. And because of this 5, okay, when we're inside of the function, that's a left-right motion, left or right, but it's going to be the opposite of what you would normally think. So a plus 5 in here is actually going to be to the left 5. Alright, so compared to the parent function, this function will be the same thing except shifted left 5 and up 3. So if I were you, the first thing I would do is I would graph the parent function just with the dot, sort of the skeleton. So remember the parent function that we just did, we had these points here, 0, 0, 1, 1, 4, 2, and 9, 3, these points. And because we sort of memorized the way they work, 0, 0, and then remember the 1, 3, 5, so it's over 1, then over 3, and then over 5 from there. It's like up 1 over 1, up 1 over 3, up 1 over 5. Just for quickness, we're going to memorize that. So this is the skeleton of the parent function. So all we need to do is take these 4 points and shift them left 5 and up 3. So let's just start with a 0, 0. If we go left 5 and up 3, that's going to be right here. Now the rest of the points will follow in the normal pattern. So I'm going to go up 1 over 1, then over 3, and then over 5. Okay, it just allows me to do it quickly. So this will be the graph of our new function. Okay, we're also supposed to state the domain and range. So the domain is the x value. So it goes from left to right. It's from -5 to infinity. And then the range is the y value. So bottom to top, that's from 3 to infinity. So that's how you do number 1. Alright, so again for number 2, let's start by sketching the skeleton of the parent function, which is 0, 0, and then over 1, 3, 5. Okay, it's worthwhile to memorize the parent function. And then this means it's going to be a shift up 1. So if I take the parent function and shift up 1, then that's just going to be here, 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 and here. Okay, so the domain is going to be from 0 to infinity. Alright, left to right. And then the range, the y values, go from 1 to infinity. So that's number 2. Alright, so number 3, I have the familiar horizontal translation. Alright, this -4 on the inside of the function is going to be a shift that is right 4. Now this 3 in the front, this multiplier, is going to be a vertical stretch by a factor of 3. Okay, this is a vertical stretch by a factor of 3. Alright, now instead of simply sketching the original parent function, which goes like this, and we've memorized this, it's up 1 over 1, then 3, then 5. Okay, that was worth memorizing, but I'm not going to sketch this time. When you have an a value, okay, and when I say the a value, I'm referring to this general model where we have a and then x minus h and then plus k. This is the general model of a radical function. So this 3 is the a value. So when you have an a value, what I would recommend is go ahead and change your table. Alright, when we did the parent function, we started with 0, 1, 4, and 9 because those are nice easy numbers to take the square root of. And we got 0, 1, 2, and 3. Now, when we do this, I would recommend starting off with the same thing. Let's still do 0, 1, 4, and 9. And of course, when we do the square root, we're still going to get 0, 1, 2, and 3. But instead of graphing that, let's go ahead and apply the a value. So let's take this middle column here and multiply them all by 3. So the only thing I'm not doing is I'm going to save the vertical and horizontal translation, the shifting. I'm going to save that and do that by hand. But any a value, I would go ahead and do that on the table. So if I multiply all these by 3, then of course 0 times 3 is still 0, 1 times 3 will be 3, 2 times 3 will be 6, and 3 times 3 will be 9. So these are the values that I'm going to graph instead of these. Okay? And I'm still going to only graph it as a shadow, just a skeleton. Alright, so 0, 0, and then 1, 3 would be right here. So you see how it's stretched higher than it was. And then 4, 6. It's going to be all the way up here. And then 9, 9. Okay, so 9, 9 is like this. Alright, so this is the unshifted version. Okay, this is, I've applied the stretch, but not the shift. So now I'll go ahead and do the shift on the graph by moving everything to the right 4. So if I take this one and I'm to the right 4 and to the right 4 to the right 4, and this one if I move to the right 4, it's going to be off the graph, but that's okay. Just estimate. So this is what our graph is going to look like. And then so the domain, the x values go from 4 to infinity. By the way, notice I'm using a bracket for the 4 because 4 is included. It's not an asymptote. It's not 4 is not an illegal value. If we use 4, 4 minus 4 is 0, and the square root of 0 is 0. 3 times 0 is 0. These are all valid numbers. And then the range, it goes from a y value of 0 to infinity. So there's our domain and range. So that's the answer for number 3. Alright, number 4 has no a value, so we will simply use the transformation. This will be left 2 compared to the parent function. So let's do the skeleton of the parent function, which is up 1 over 1, and then 3, and then 5. Alright, so that's what the parent function looks like. We've memorized that. And now we will go left 2. So if I go left 2, I will start here, and then I can still do the 1, 3, 5 pattern. 1, 3, 5. Okay, so my domain, the x values go from -2 to infinity. Bracket on the -2. And the range, the y values go from 0 to infinity with a bracket. So that's the answer to number 4. Number 5 actually is the parent function. So let's just write parent function. Alright, and we've memorized the parent function from the first time that we did it. It started off at 0, 0, and then 1, 3, and 5 from there. Okay, something like that. Kind of messed that up a little bit, but you get the idea. And of course the domain, the x values go from 0 to infinity. And for the range, the y values go from 0 to infinity. So that's the answer to number 5. Alright, so for number 6 has an a value, the 2, a multiplier, a vertical stretch. So I'm going to make a new table of values for this one. But let's go ahead and say what the transformations are. This plus 2 on the inside is going to be a translation that is left 2. Okay, and this a value of 2 is going to be a vertical stretch. By a factor of 2. Alright, so those are the two transformations with which we are dealing. But anytime you have an a value, I recommend making a new table. Sort of like this, a 3-column table. In the first column, we will put our usual x values. In the second column, we will put the parent function. And in the third column, we will apply the a value, so 2 times the parent function. So let's use the same 4 x values that we always use because they are easy to take the square root. And that's going to be 0, 1, 4, and 9. Of course, if we take the square root of those, we get 0, 1, 2, and 3. But now, we will apply the a value and multiply all these by 2. So that's going to be 0, 2, 4, and 6. So these are the values that we will sketch. Now I'm only doing the skeleton at first because this is not the final answer until we do the shift left 2. Alright, so let's do the skeleton of 0. Okay, so 0, and then we have 1, 2, and then we have 4, 4, and we have 9, 6. So this is our skeleton. Don't draw it in, just put the dots. That's why I call it a skeleton. And now we'll do the shift left 2. So I'm going to take each of these 4 points and move them left 2. And then that will be my actual answer. So I will connect these. Alright, and now I can talk about the domain. The x values go from -2 to infinity. And the range, the y values go from 0 to infinity. So that's the answer to number 6. Number 7 just has the 1 transformation. This plus 5, notice that it is not under the radical. The radical is not extending out over it. So when you have a number added outside, that is going to be a translation up. In this case, up 5. So let's go ahead and do the skeleton of the parent function, which we have memorized, starting from 0. Then it's up 1 over 1. And then over 3, and then over 5. Alright, it's the 1, 3, 5 rule that helps us remember the parent function that we graphed at the very beginning. Alright, and then we'll go ahead and do our translation. When you do the parent function, don't connect these dots. Just put the dots alone so it's easy to tell the final answer, because it'll be the only one that's actually drawn in. So if I go up 5, alright, the initial point will be right here, up 5, and then the rest will still follow the 1, 3, 5 rule. So I can easily just go up 1 over 1, and then 3, and then 5. Okay, it just allows me to draw the graph very quickly. And then we can talk about the domain. The x values go from 0 to infinity. And the range, the y values go from 5 to infinity. So that's the answer to number 7. Alright, so we'll be careful. Number 8 has an a value. So we will make a table of values for that one. But let's describe the transformations first. So this positive 1 on the outside is going to be a translation up 1. this negative 1 on the inside is going to move the function right 1. Okay? Remember, these left-right motions from the inside of the function always go the opposite way that you would normally think. So negative 1 actually moves us to the right by 1. And then the 1/2, this a value in the front, that's going to be a, well, instead of a stretch, if this were multiplying by 2, that would be a vertical stretch. But because this is less than 1, it is a vertical compression. Alright, vertical compression by a factor of 1/2. Okay, that means the graph is going to get smaller. It's going to shrink to 1/2 of its original height. Okay, so anytime we have an a value to deal with, I recommend making a new chart. So first we will use our usual x values, and then we will have the parent function, and then we will apply the a value to that. Okay, so using our normal numbers that we use when we've graphed our very first parent function, 0, 1, 4, 9, because of the way they make nice square roots, we can take the square roots. We will use those same values again, so we will use 0, 1, 4, and 9. So of course, if we take the square root of those, we would get 0, 1, 2, and 3. But now we're going to take half of those. Half of 0 is 0. Half of 1 is 1/2. Half of 2 is 1. And half of 3 is 1.5. It's 1.5. I don't like mixing fractions and decimals, so my OCD requires me to go back and call this 0.5. Alright, so these are the values that I'm going to be sketching. Now, this does not include the shift that's right 1 and up 1. So I'm going to just do a skeleton using these. I'm only going to plot the points. I'm not going to connect them. So starting off at 0, 0, and then 1, 0.5 would be right here in the middle. And then 4, 1 would be right here. And then 9, 1.5. So here's 9 and 1.5. So this is the unshifted function. Do not connect those dots. It's just a skeleton. So now we will take that skeleton and shift those 4 points right 1 and up 1. So if I do that to each one of these, so right 1 and up 1, that point will be here. Right 1, up 1. Right 1, up 1. Right 1, up 1. So this will be the final answer. Okay, and now we can talk about the domain and range. The x values for the domain go from 1 to infinity. Looking at the range, the y values also go from 1 to infinity. So that's the answer to number 8. Okay, number 9. This has an a value, so just like we did on the previous problem, I'm going to make a new chart for this one. But this also has +4 on the inside. That's going to be a translation left 4. But this will be a vertical compression by a factor of 4/5. This is less than 1, so it should be a compression. Okay, vertical compression by a factor of 4/5. So, because we have the A value, let's go ahead and make a new table. Alright, so we'll have our X and our parent function, and then we will apply the A value of 4/5. So for the square root function, it's convenient to use 0, 1, 4, and 9 because of the ease of taking the square root. Okay, so that's going to give us, for the parent function, 0, and 1, and 2, and 3. But let's go ahead and apply the 4/5 to that. Now, of course, 4/5 of 0 is 0. Alright, 4/5 of 1 is just 4/5. Alright, 4/5 times 1, you could think of it that way. I'm going to use decimals though, so if we toggle it, we see that is 0.8. Okay, and now let's do 4/5 of 2. Okay, and that's going to be 1.6. And 4/5 of 3. That is 2.4. So this is the skeleton that we will be graphing. Alright, this is still just a skeleton. I will not connect these points because I haven't done the shift left 4 yet. So we start at 0, 0, as we often do, and then we will do 1, 0.8. So over 1 and up 0.8. Okay, over 4 and up 1.6. So that'll be about here. And then over 9 and up 2.4. So here's 9 and here's 2.4. So this is our skeleton from which we will begin. But we will take each of these 4 points and shift them left 4. So if I take this and go left 4, I will be here. Okay, and again left 4 and left 4. So this will be the graph. And so now we can talk about the domain and range. For the domain, the x values go from -4 to infinity. And for the range, the y values go from 0 to infinity. So that is how you do number 9. Okay. Last one. For number 10, we have 2 transformations. We have a nice simple +5 on the inside will be a translation that is left 5. This a value, this multiplier in the front, again is going to be a rather ugly vertical compression. This is less than 1, so that won't be a stretch. it is a vertical compression. Vertical compression by a factor of 2/5. Now, anytime we have an A value like this, I recommend that you make a new table of values with 3 columns. Alright, in the first column we'll put our x's, in our second column goes the parent function, and in the third column we apply the A value. So in this case we will do 2/5 of the parent function. Okay, so I like to use the values of 0, 1, 4, and 9 because they're easy to do the square root. So the square root of 0 is 0, and then 1 and 2 and 3. So I'm going to do 2/5 of each of these. Of course, 2/5 of 0 is 0. Okay, 2/5 of 1 is just going to be 2/5. But let's, if we look at the decimal version, okay, you can think of it this way: 2/5 of 1 is 2/5, like I said. But as a decimal, that's 0.4. Okay, now if I want to do 2/5 of 2, okay, that's 4/5, which is 0.8. And if I do 2/5 of 3, alright, that's 6/5, which is 1.2. Alright, when I do the graph right now, I'm only going to graph the skeleton because I'm not doing the shift of left 5 yet. Okay, so we'll start off at 0, 0, and 1, 0.4. It's a little less than half. And then 4, 0.8. Okay, which is almost 1. And then 9 is 1.2. So that's just a little bit above 1. Okay, so these are the original values. Now we need to shift these to left 5, and then that will be our answer. So if I shift left 5, I'm going to start off here. And then if I shift this one left 5, it will be about here. And if I go left 5 with this one, it's going to be about here. And left 5 with this one is going to be here. Okay, so our graph is going to be looking something like this. And then we can go ahead and do the domain and range. So the domain will be from x value of -5 to infinity. And the range, the y values go from 0 to infinity. Alright guys, that was the last one. I hope this was a helpful video for you, and I will see you on the next video.